Thanks everyone for coming. We're going to get started. We got a lot of great info for you today. I really need a gong.
Yeah. Hey guys, we're going to get started. So if you guys can find a seat if they're available.
So thank you all for coming. This is an exciting meetup because every time there's more people here, and I love the high growth and the interest in chatbots and AI and just how we can get things done in this domain. And it's everywhere. It's Microsoft, it's Google, it's small startups, it's Facebook, Amazon. This is really like democratizing again. It used to be like you make a website, anyone can do it. You make a mobile app. Well, now it's getting a little harder, and then everything, like the bar keeps getting raised, right? If you want to make a fancy app now, it's tough to compete. It's a lot of money. You got to have a Super Bowl ad. Probably need funding before you have a Super Bowl ad. You're not going to do a garage startup and have a Super Bowl ad. You know, on chatbots, you can get a lot of interest in entertainment and people engaging with it. So I think it's a great space. So we're hosted here by Samsung Accelerator. So they provide capital product operational support to entrepreneurs focused on VR, AI, IoT payments. And they're part of the Samsung Global Innovation Center. If you want any information on them, you can have a look at this slide and certainly reach out to me after if you'd like me to put you in touch with anybody. And here's our agenda for today. So we just finished networking, pizza, and beer. Success. Now we're going to have some demos on bots, and I'd like to introduce Javaughn actually, who's a member of our group, who came up to me and said he really wants to be part of this, and he's been already a great help growing the group and setting up this bot demo idea, so I'll pass it on to him.
Hey guys, as Alec said, my name is Javaughn, and I came to the first meetup for this group like a month ago. And I just was really fascinated by the level of kind of passion that people had and just the ecosystem in general. And so that's why I decided to just come out here to really support and help build the ecosystem as much as possible. So as Alec mentioned, one of the things that we really strive to do in our group is really to develop a community, right, of bot creators that we could share resources and could trade ideas to make our products better.
Hi guys, I'm Keith Brisson. I am co-founder and CEO of init.ai. We're based here in New York City. We provide language understanding technology to companies building bots, helping them support and analyzing conversations. Today I'm actually not going to talk about the company. I'll give you a little bit of an intro to init.ai. I'm going to talk more about the bot space, and then I'm going to talk about how machine learning fits into it. So a lot of you guys are probably familiar with machine learning in the context of APIs you've used. I'm going to talk a little bit about the techniques that are going on behind the scenes there, what that looks like now and what it looks like going forward in the future. So be prepared. I will talk about neural networks and what they look like. No math.
Keith, a little bit left.
Sure. So as I mentioned, init.ai is a platform for conversational understanding. We think about the space pretty generically. We're looking to help with bots as well as natural language conversation between people. And we look to do that by automating conversations like bots, assisting sales and support people in live chat, and analyzing conversations between two people. So if you have two people texting back and forth, we can pull out data from within that conversation. It can be used to detect events in the conversation, be used for analytics, etc. You guys are into bots though, and the shift towards natural language conversation between people and businesses has been going on for a while. This year we kind of had a boost on the automation side with a proclamation that it is the year of conversational commerce. I think everyone remembers kind of the start of 2016 and all the hype around it. But the idea behind talking to a computer is not new. It's been going on since Star Trek back in the 60s. How it's been implemented has changed over time though. So one of the first chatbots was Eliza in 1966. All procedural, used tricks to kind of understand what people were saying and then respond to them based on heuristics to kind of give clever responses that seemed interesting. It was a psychiatrist too, so it could just keep asking you questions and kind of get away with it. More recent, the biggest chatbot ever is probably Smarter Child. This was on AOL Instant Messenger around 2000, and their user base got to 8 million users. Like they have a huge volume of the AOL Instant Messenger traffic. Again, all procedurally based. It wasn't Eliza, but it was still kind of rules based. offered services in all kinds of arenas. And then more recently, you've seen interactive assistants, Siri, Google Now, Cortana. These, if you think about them, they are essentially bots. They're just voice bots. Now they're more interesting in that the capabilities are becoming a little bit greater as you get into these assistants. This year has been interesting though, because everyone started seeing all the advances in machine learning and using terms like AI-powered cognitive computing. Thanks IBM for making that, and learns from you. These kind of terminologies to describe what was powering the bots behind the scenes. The fact is, computers don't think yet though, so it's kind of BS. Bots are really made with things that look like this. So on one side you have kind of drag and drop tools for simple use cases. There's many companies trying to approach this space. One of them, at least one of them is here in New York. And then you have developer tools. So you have programming combined with APIs to try to understand natural language. And that's really how the bots today are being created, with very few exceptions. It's not machine learning all the way, it's programmatic tools. I'm going to primarily focus on the developer tool side because that's where the machine learning is coming in. And init.ai is a platform that seeks to serve those kind of folks. So the landscape for developer tools, it varies in terms of capabilities right now. You have frameworks to control conversation logic. You have services that combine frameworks and then host them. You have NLP libraries that try to just parse sentences procedurally. You have open source projects that aim to define what bot conversations should look like. So AIML, RiveScript are examples of those. And then you have APIs that do language processing. So the big ones, they're all owned by large companies now except for us. With.ai, API.ai, IBM Watson, Microsoft Lewis, and most recently Amazon Lex. And I'm going to get into a little bit about what kind of capabilities these guys are offering behind the scenes in a minute. What we offer is these language understanding capabilities and then a bunch of tools around it. So tools to manage conversation state, we'll host, although you can host it on your own as well, and then connections to messaging. But primarily, like, our value add is packaging all this together. And once I talk with machine learning, you'll kind of see where we're headed on that front, and why we package it all together. So components of what we do, when you have a user interacting with a conversational interface like a bot, you have to get the response from the messaging application. You have to extract meaning from it, so understand what the user is trying to do or say. You have to decide how to respond to the user, and you have to generate a response, and you have to send it back. We take care of that whole flow. We take care of that whole flow, but we're seeking to address kind of fundamental questions on how a bot behaves. For a bot to be successful, or any conversational application to be successful, it needs to do a few things. It needs to understand language, so what is the user asking? It needs to have logic, so what actually needs to be done? And it needs to generate language, so how do you actually respond to the user in a natural way that the user can then understand? Because the user has their own language understanding built in. There's some more interesting things about predicting what happens next, but most bots don't actually need that. I'll touch on that in a bit, though. Can everyone hear me? So, the first thing, language understanding. What is the user asking? This is one of the stumbling blocks for natural language bots today. It's really hard to understand natural language. And there are different ways that you can take it. The most simple approach and naive approach is basically keyword matching. So looking, does a piece of text contain a particular keyword, and then taking some logic based on that. So the message, what are your hours? You could say, that if it contains hours, then the user is asking about hours, right? It doesn't work so well if they ask, I've been waiting for hours for my delivery and I'm getting really frustrated, because that's going to match that keyword, but it's not what the user meant at all. So that's a fail. How can you improve it? You can match on two keywords. So you can say, you can say what as well, so it'll match what are your hours. It won't match, I've been waiting for hours for my delivery and I'm angry now because the word what's not there. But if the user asks what time are you open, well, that's the same meaning from the user, but it's not going to work, right? So you need something that's a little fuzzier. Beyond that, what if the user asks something specific about like a time? You get into a mess that looks like this. So what are your hours on Monday? What are they on Tuesday, Wednesday, all this? You get into these trees that are kind of a nightmare to deal with. So keyword matching, it's simple to get set up, not going to go very far. Fundamentally, what's happening here is two things: intent determination and slot filling. So intent determination means taking a piece of text and determining what the user is trying to ask. So if you guys have used natural language APIs, they generally have a concept of an intent. That is a piece of text that has classified the message as meaning, like in this case, I want to find a flight. This is actually from an academic data set called ATIS, which is it's like 20 or 30 years old, but it was a standard for a while in terms of measuring the performance of these kind of NLP systems. There's also a thing called slot filling. So slot filling is extracting out information or bits of the message that mean a certain thing given the semantic context. So the sentence here, show flights from Boston to New York. Boston and New York are both cities, right? One is the departure city, one is the arrival city. So the process of finding those pieces of text is called slot filling. And if you think what keyword matching is fundamentally, it's doing both of these things. You're looking for intents and you're looking for the slots. So you can go beyond keyword matching to regular expressions. I'm not going to show any here, but it's basically the same concept as keyword matching. That is, you end up having similar kind of, if this regular expression matches, then maybe pull out data from it. So regular expressions can match patterns. Like if you have one word, then a city, then another word, you can extract that city using a regular expression. It ends up being a manual process as well. So some people have built tools to make that simpler. Well-known one, AIML, is an XML-based definition language for intent determination, slot filling, as well as sending out responses if it meets a pattern. That's XML-based. Rivescript is one that's Markdown-based. So you can see there's actually slot filling going on here. So my name is Star. Star is implicitly like a name slot. And then the bot is responding, nice to meet you, Star1. Okay, so it's slot filling fundamentally. And the intent is just if that sentence matches, then it matches the intent. So there's implicit slot filling going on in these systems, but fundamentally at the core is regular expressions. Just a lot easier way to do it. You can also offer alternatives in systems like Rivescript. So if you have different words that mean the same thing, you can manually add those. Some tools try to extend this using basically dictionaries and synonyms to make it even more powerful and flexible. Ultimately, though, machine learning is the way forward. With machine learning systems, you can do all of this in a more flexible way. And over time, these techniques will dominate. So I'm going to talk a little bit about what those techniques look like. I'm going to not get into any math, but you guys can ask questions if you want. First question is, how do machines understand words? As what I said before was that machines aren't good at understanding language. What they're really good at is number set. So a few years ago, researchers came up with the concept of embedding words within a vector space. So a vector space is a set of numbers. It's like, the world is 3 dimensions. Well, you can have more than 3 dimensions. You can have 50 or 200 dimensions, and numbers corresponding to points within this space, and those numbers match up to words. So researchers developed techniques to take bodies of text and then determine the numbers that match up with the words. And it turns out you can do cool things like, it turns out similar words end up in similar places within this space of numbers. And it lets you do relations like king. Okay, so look at on the left here. If you take the numbers that represent king and add the difference between the numbers that represent man and woman, you get queen. Okay, so it lets machines actually do analogies on words, and it's based on where these words and concepts live mathematically in relationship to each other. But fundamentally, the goal here is to take words and turn them into numbers in that term. Using those numbers, you can use a neural network to actually take meaning from them. So I'm sure everyone here has heard the word neural network. What it is, it's just a math problem where you're taking numbers, combining them using different equations, and getting results from them. It mimics a biological neuron, but these can take, there can be a biological neural network, but that you can have multiple levels of these, and you go through a process of training them, and what you end up with is basically a complex set of equations that, given an input, will produce an output. And you train it on examples you've seen, and then give it examples you haven't seen, and it will basically classify whatever input you give it. The process for training these is basically trying to make it not error. So if you give a neural network an input, it will give you an output, and then the process for actually training a neural network is to find out how different those are, and then make adjustments to the neural network over time so that the next time it sees it, it's closer. So that's kind of a high-level overview of neural networks and what training looks like. As far as how they're actually useful, oh, one more thing. I just want to show, this is actually a graph of a neural network being trained. The notion is that the more times it's seen data, the lower the error rate is. So if a neural network is trained properly over time, the error that it has in understanding the data it sees will go down. And you end up with charts that look like this. Neural networks have been big in vision. So in vision, they can be used to understand the meaning of images and pull out like what kind of objects are in what kind of images. Convolutional neural nets are a technique, a neural network type that can be used for this, but they can also be used for text. So what a convolutional neural network is taking different, in the image, it's taking different pieces of the image, mixing them all together at a low level, and then doing that at higher and higher and higher levels, and then pulling data out of the top. And then you can train it to understand the meaning of the image. In language, you need training data as well. So at init.ai, what we do is we use Markdown to define language training data. So this is an example like a finance application. Developers using our technology can provide example conversations as Markdown, as plain text, and they annotate it with intents and with what are essentially slots. So these link syntax is slots. And then that can be taken and fed to a neural network to understand exactly what's happening. So yeah.
So I've heard speakers, faculty from NYU speak that they're using convolutional neural networks for music in terms of machine learning.
Yeah.
So I'm not sure where the point where you can incorporate that
in music. Yeah, you absolutely can. So I'll get to that later, but the interesting thing about machine learning is that it ends up being that anything that can be converted into numbers can be incorporated in a model like this. So you end up being able to mix sound and text and images all in the same system if you want. What happens in the text world is you take the numbers that represent each word in a sentence. You can also do this per character, but in general you would do it per word. And then you combine all these numbers in different convolutions, so it's mixing them together. Do that multiple times, and then you can determine the overall meaning of the message. You can also do this with slot filling. So let's look at this example sentence. Just trying to reiterate what a slot filling mechanism is here. And then you can see that with a convolutional neural network, you can end up doing both things independently or together if you design your network right. So you take the numbers for each word in the sentence, combine them all together, and then at the top you can get a prediction to what it actually means. And what the neural network is doing is actually predicting the closest type that it's actually seen in its training data. So it's really it's like statistics. It's like if it's seen 10 different types of sentences, it'll find the kind of sentence that it most closely matches for any new sentence that it sees coming in. It's not doing anything beyond that. It's just correlations, essentially, very sophisticated correlations. In the slot filling situation, you do something similar, where you look at groups of words, and you use the context of them to determine, like, okay, if Seattle is here, you look at the context of that, run it through a convolutional neural net, and can determine the closest slot type for that word to, which can actually be no slot. So like the word to doesn't mean anything in that sentence, and if it saw that word, it would actually predict that. So convolution is one way you can do this. There are other types as well. Recurrent neural networks are the kind of the new hot thing, which are good at operating on sequences of things. So you give them a piece of data, and then you give them another piece of data, and then another piece of data, and they give you an answer for each one over time. And they can actually have memory, so they can remember things in the past as well. It's a little more sophisticated, but they're really good for kind of sequences of things like text. So the question is, how do you use this? Now, instead of keyword matching, it becomes intent matching, right? So you say, if the message intent equals ours, say this. Now all of these cases work. Assuming that you have the training. You're still stuck with this situation now, which is, what do you do about the slots? Now you're not keyword matching on days of the week, but you're actually matching on slot values. So if the day is Monday, then say this. If the day is Tuesday, then say this. The traditional tools have mechanisms kind of for doing that implicitly. The question is, how do you respond to the user? So back to, this is an example of ride script, but what you're doing when you have an NLP API like what I just showed, where you're spitting out an intent in slots, is that you then have to deal with programmatic code to respond to it. So just JavaScript to take values and then send back a message is a common case. This is from Microsoft Bot Framework. This is an example of how we actually think about it. So this is from our JavaScript SDK, where we provide something that's like a state machine, where each portion of the conversation is modeled as a step in that. And the developer can get slot information, and they can instruct the system to generate text to send back to the user, given a set of data. And init.ai is actually doing the text generation in that setting. So the question is, what's next? When you have the separation between the language model and the logic, you're relatively limited. That's not going to last forever. If you look at this, would you actually say it's intelligent? Like it's not really learning. It's not a brain. It's not really an AI in a conventional sense. But what's happening is we're moving towards that. So beyond the convolutional side, there are different types of networks that can take in text and then spit out text. We actually use this is from Google's inbox auto reply. I don't know if any of you guys have used that. Take in an email, spit out a prediction of how you should respond to that email. We don't use exactly this kind of network, but something similar to do our intent determination and slot filling as well. But this architecture can be used for things like language translation as well. So if you type into Google, you want to translate one thing into another, what's actually happening is a recurrent neural network is looking at all the words in the input message, then forming a sequence of numbers that represent the meaning of that message, and then outputting another sequence of words. It's called the sequence-to-sequence model. And there are different variants of that don't use recurrence, so you can actually use a type of convolution to do the same kind of sequence-to-sequence thing as well. This is a newer advance. But beyond translation, you can have a neural network actually spit out text to respond. So if you want to make a bot that entirely speaks for itself, that's something you can do, and researchers have done that. So in this case, researchers took a neural net like what you just saw for translation and trained it on Twitter conversation snippets, and then started asking it questions. So you have text coming in, and then you have predicted answers coming out, and you end up with conversations that each message makes sense. Like the question and answer pair makes sense, but beyond that, it doesn't really make any sense, right? And it's not actually thinking; it's just doing correlations based on what it's seen from Twitter, essentially. So someone on Twitter has probably said, "I live in Los Angeles," after being asked the question, "Where do you live now?" The problem is there's no real logic here, so you can't trust them to actually do the work. This is changing a little bit, so you can actually have machines actually reason about data contained within text and actually give you like a logical answer. So Facebook demonstrated an example of this, actually their AI team here in New York did, where you have basically sentences, which is like describing a situation, then you ask it a question and it actually spits out a text answer. And you can do interesting things like make logical deductions. Sheep are afraid of wolves, cats are afraid of dogs, mice are afraid of cats. Gertrude is a sheep. What is Gertrude afraid of? Wolves. That's entirely from the neural network. No programming required. It's just looking at the text to do that. The basic co-reference one. Daniel was in the kitchen. Then he went to the studio. Sandra was in the office. Where is Daniel? The studio. So you can answer these kind of questions and actually do basic deductions. You can't really do anything beyond that, but it's getting there and it's coming. A more recent advance is the actually it was at the same time. Neural Turing machines, another approach to that. So I mentioned before that neural networks tend to be just correlations. Well, it turns out that they are starting to be able to learn algorithms too. So ways to take data and then actually process it and act on it. Doing things like math, doing things like addition, recognizing patterns, and spitting out answers. The neural Turing machine it adds like a kind of memory to a neural network, so it can remember values over time as it processes things. So one of the things that the researchers tested was something like, basically remembering that, a certain value is associated with another value, and then giving it a whole bunch of those things, and then seeing how accurate it was, and then spitting out the answers given those values in the future. If you look at the kind of the existing state-of-the-art technology was what's called an LSTM. It's a type of recurrent network. That's the blue line, and you can see this is error again, so you want lower is better. Even after training for a really long time, it still had a lot of error. This new type of architecture, the error in the blue and the red lines dropped almost to zero, almost immediately. So there are changes happening in how neural networks are architected that actually allow them to learn processes. Another example came out this year where neural networks can actually do reasoning over things like transit systems. So you give it a list of connections in like the London subway system and then ask what is the route from here to here, and it will actually give you a logical, coherent path. And that's just the start. Like they can reason about things like family trees. Like here this question is who is Freya's maternal great uncle? Okay, and then the neural network was able to, given that representation, actually answer that Fergus is maternal great uncle. I don't know if I can answer that. Like I don't know what it means. But it was actually able to follow through that. And what this means is that anything that can be represented like this can become something that's learned by a neural network. And that means that all of that programming that you're doing to make your bot get up and running eventually is something that the neural network could actually learn. So when we look at bots, like we're an infrastructure provider, when we look at bots, we see a ton of small companies, but we see large companies getting very, very serious about this as well and devoting a lot of resources into getting bots up. In the short term, we think that humans are going to be a big part of that, and that will actually help transition us into full automation over time. And on the machine learning side, it's our belief that eventually the machine learning, like what I just demonstrated or showed with the kind of logical inference over a piece of data, is actually going to replace the logical things that you have to program right now. So that's where we think the machine learning, how this is going to play in. We think you're going to see more and more machine learning over time. I'll show you this after, but any questions on this one?
So you said that you guys do language generation, and
Yeah.
I wonder if you're doing that, you're running it through a neural net. Are you treating that as a classification problem or a regression problem?
Yeah.
And if so, if you know offhand what kind of F scores you guys are getting in terms of accuracy of your
Yeah,
predictions?
so the short answer is we are doing language generation, but what is currently in the product is not neural network based,
So you're still working on that?
but it's coming. So we're starting out by correcting errors in the text. So
Could you say offhand what you're using as training data for your language?
Sorry.
So specifically about language generation, and also it's directly related to intent determination as well, right?
Yeah.
I mean, if you're dumping data in, presumably there's a statistical analysis that determines the probabilistic likelihood that a particular input should be associated with an output.
Right.
And if you're dumping a ton of data in there, you could get varying levels of certainty with which like a particular response is appropriate. So like how do you do the editing that you just referred to? How do you, like when you have so many possibilities, how do you know whether the responses that are going to be generated are good ones? When there's so much data.
So, I mean, the short answer is that the kind of, this is, you know, this is kind of like the limit of how logical these things can get. You can get more sophisticated where you can follow logic through them, but it's not there yet. So the models that are generating full text from input sentences are not there. The models that are doing classification of intents, are you asking about the text-to-text like full generation, or are you asking about how do you measure intent determination, confidence?
The intent is determined from a particular set of inputs,
Right.
set of questions,
Right.
and those are associated with a particular correct response. So in a sense, like the AI is creating a hypothesis.
Yeah.
Like this is an appropriate response. However, that hypothesis could be wrong.
It could be.
And if you are not if you're not creating all these hypotheses, how do you edit them? How do you confirm that how do you go in there and how do you find the ones that are wrong for you? Assuming there's thousands, for example.
So when a machine learning model is predicting what the output should be given an input, it is assigning a confidence score that is based on its how sure it is relative to the other options. Okay, so if there are 10 possible outputs, it will assign a weight to each one of those, and it all adds up to a probability of 1. So most of these models, you have 10 options, and it has to select one of them. You could make a special one, which is I don't know, okay? And what is the probability that I don't know completely? If you don't, then the confidences are weighted between those. And you end up with how much weighting is assigned to each one of those. And if it's not sure, like if the input doesn't match the training data that's come in at all, there's a good chance that what it generally does is assign confidence. It thinks all of them might be right, okay? And that's why if you have 10 of them, maybe the confidence of the top one is like 11%, and then the other ones are all like 9% confident. So it just really, it can't decide between all of these. There's no clear winner. So that's how the model is determining how confident it is. It's basically, given all of the choices, how much weight am I, how certain am I that there's only one correct choice? That's on general classification of text. Does that make sense?
Yeah, but I guess I'm just thinking in the case where you don't curate the data that you're given, the training data,
Yeah.
and you dump in data from conversations had between all sorts of weird people,
Right.
and it's possible that the data that's going in isn't good data, so that the confidence, the confidence weights are basically meaningless because the data that went in was weird to begin with.
Right. So
and in that case, it would be very difficult, I guess.
So the results are as good as your training data. Like what you have to do there is you train on some data and you don't train on others, and you look at what you're not training on. and then you look at the results of how accurately it's handling that data that you're not training on. It's a test data set. So you reserve some of that data that you want to work, but don't actually train on it. But again, like if you just assign random words and put that in your training data, a neural network's not going to learn to understand text based on random words. It's, what comes in is what comes out. And like these kind of, like this one was based on Twitter conversations. Other researchers have used like movie scripts. And then what you end up with text that the answers look a lot like they're from characters from movies. And like you can ask things like, what is the meaning of life? And you'll get a response that is like something a movie character would say. And like it's very different than if it were trained on conversations from like a philosopher, you're gonna get a different answer, or like a doctor, you get a different answer too. So there's human judgment there. The machine doesn't really know how good its training data is, at least in the sense that you're talking about. Yeah.
So where does unsupervised learning come in? It seems like this is very like someone has to check, and it seems all kind of supervised. So where do you see unsupervised learning come in?
So the first state that unsupervised learning comes in is right here. So all of these numbers are generated based on unsupervised learning. So what you do to generate the numbers that represent individual pieces of text is take a very large body of text and then find what words occur in relation to each other. So that's an entirely unsupervised process. So that you just dump in text, you get a numbers. In the other kind of models where you're actually generating text, there are things like reinforcement learning, which given what the model has tried to do, you basically reward it. You say you did a good job. Next time you see a situation like that, you should respond the same way. Or you did a bad job. Don't do that again. And then over time, it's like an online training of this as well. And that can happen using it like basically without any supervision, where it's just if like a bot could using that kind of model in the future could learn to sell to people, where as long as if it completes a successful transaction, then that's treated as a positive signal without a person sending it back.
So if someone says thanks or someone hits buy, like that's automatic.
Yeah, exactly. Those kind of processes are becoming more and more relevant. But in general, most of the technology that's actually commercially available is supervised on this side, except for the foundations of it. Yeah.
Do you have any kind of ontology or some sort of semantic model, or is this just like pure numbers in the neural networks?
Yeah. So what's interesting is that these kind of networks can learn those kind of semantic models. Like you can train a network that is like, you can train a network that's like this to parse a sentence based on, this is a verb phrase, this is a noun phrase, this is a preposition, and then these phrases are nested. You can train a model like that to perform better than any programmatic method of doing that. So the state of the art in terms of that kind of parsing is actually a neural network that's been trained on those parse results now. And so in terms of parse trees, a neural network can do that. In terms of meaning of words, it's actually embedded within those word vectors that I was talking about before. And there are ways to train those word vectors on actual like curated relationships between words and phrases to augment them in a way that's more robust than just training on massive text. So you can implicitly incorporate all of those kind of concepts in these kind of models with the right training data and the right architecture. Does that answer your question?
What is?
All right. Yeah.
I noticed you had some German up there. Do you have any comment in terms of which languages are easy to train in and which topic areas are easy to train in?
So for translation or for general?
For general.
So these techniques don't generally rely on what the language looks like. These techniques can be applied to basically any language.
I know that, but the question is, which ones does it learn easier? And what is there any reason why it learns the meter?
You know, I actually don't know that offhand. I would need to, I'll ask my linguist tomorrow, because that actually makes me curious. I'm not sure. Yeah, I would check.
imagine like agent symbolic characters where it's not so much like letters, it's like themes that come together, and that would be tough.
Yeah, I could see that being very tough. I don't know enough linguistics to know that answer. Sorry.
One pattern I've seen here is that the time it takes for machine learning to really learn is sometimes at odds with new information or scenarios that might be repeated, like getting new news or a celebrity event or a meme appears or whatever. But that might occur in minutes or seconds or hours, but you don't have 3 weeks for millions of people to have taken an action. So is there a risk that it's almost like a filter bubble that excludes new information in the moment? Or
I mean,
are there,
sure, yeah, like
work
if you
models
make
that account for that?
If you make a bot right now and train it on a set of language data, and then you give it language data that's completely different, right, it's not going to do very well. Given the existing techniques, that's changing. There are techniques coming out that can learn from single examples, and there are ways to pre-train networks on kind of like logical like meanings of like like sentence structures, and then they can greatly accelerate the understanding of single examples in the future. Like from a philosophical standpoint, I guess yeah, you could end up with like kind of filter bubble. I think that's like the nature of the technology in the short term, especially with supervision. Adding in the human to do that kind of update really slows the process down. As you get to kind of the thing training itself, then I think you can adapt to that a little bit better. I think it's a temporary problem though. Like you're going to get the kind of the base models are going to be built out, and then you get to see new kind of text and topics and pick them up rapidly. Yeah.
So like one of the problems that Google was having when they were developing their auto response was they were spitting out "I love you" at random times. Was that something that, given the depth of information that they were feeding it couldn't infer the context? If you're small compared to Google, Amazon, and Facebook,
Yeah.
how are you dealing with that? Not having that ridiculous amount of information to work with.
Like how do we detect when some like rare event like that occurs? Or
I'm curious, you're participating in a space that it's really largely about how much data you're feeding your models, rather than the depth of the data that you're feeding your models largely determines how good they're going to get.
it is to some extent.
Brushing up against that, or
Yeah, so it is to some extent, it depends on the application. So we're providing the technology to individual businesses, essentially. So our, the data sets that they themselves have are relatively small. Our challenge is how do we take their small data sets and make it easier for them to train given their small data sets. And for that, we use larger data sets that we have to basically pre-train the foundations of that. We don't have as much data as big players, but what we do have is the kind of the way we approach that is to design our system such that we can work with small data. Because at the end of the day, like our goal is not to know every domain. Our goal is to provide the tools that let individual companies work with their individual domains. So the models that we're training for other companies are very domain specific. That makes sense.
So I mean, you guys are using transfer learning transfer learning to pre-train this model?
We're doing various types of pre-training. So we have core data sets that we do pre-training on, and then we have different techniques for actually letting the company have their training data on top of that.
When you refer to the single case example, so are you looking at machine learning for extreme responders? Is that related to
what is?
Well, you mentioned that the new techniques are training on single case examples. So they're machine
Yeah.
learning specialists who focus on extreme responders. We're going further out until the graph is very narrowed down.
So like it's the techniques we're waiting for are all related to one-shot learning, like basically looking at single examples and learning from those. We don't have those implemented in the platform yet. So we don't know exactly what form that is going to take. We're using different techniques to try to amplify data sets right now. So I might be missing your question.
Yeah, I've met researchers, mathematicians who focus on extreme responders for clinical trials. That's extremely important.
Yeah.
And we have a blue survivor cases. Statistics of the survivors are very low. So if it's a single case, it seems like that is an extreme, maybe an extreme responder.
It might be. I just might not be familiar with that. I'm not the expert within my company, so I might not be familiar with that. Sorry. What else can I? Yeah.
What's your take on the current state of patents? Like after that Alice Corp decision, it's hard to get patents for algorithms for software products. Like, how you guys going to protect your IP? What's your feeling as a CEO?
So as a CEO, I'm not trying to compete with Google and Facebook and Microsoft. In terms of like developing new algorithms, we do generate things internally that they don't have. Like we combine techniques in ways that they haven't before, and then we've seen them publish something that we did a couple months later. So that has happened. But what we try to do is take that technology and bring it into the market in a way that companies can actually use. And we're much more nimble than we were. And that's where our competitive advantage is. So in terms of like patents on this stuff, all the companies are kind of throwing all of this data out there to promote the research on it. And I'm supportive of that. I mean, that's something that once we get to the point where we're like actually have time to publish papers, I would love to do that too, because that IP, it changes so rapidly. Like whatever techniques we use today, like we've already, in our short lifespan, we've already redone things many times, and we'll continue to do that. So what is, important today is going to be different tomorrow, at least from these core technologies. How it's productized is something that we're much more protective of. Yeah.
What are your thoughts on like the continued idea of eventually we'll just drag and drop a thing in some content of a person to make this incredible innovative experience? It's happened with like programming languages and websites and mobile apps. Like,
yeah.
Are we like actually on a trajectory to get there, or is it always going to be something like, oh, it's always 10, 20 years out?
I think I look at that in terms of the history of visual programming. Like people tried in the 80s, and they tried in the 90s, and they tried in the 2000s, and just like for like simple like database programming, like any of those kind of tools, and people tried drag and drop programming for many things before. Natural language is like the most complicated thing you can do in computer science, or one of the most complicated things you can do in computer science. It's my belief that the tooling is not going to get to that point in terms of a robust experience. That said, for certain cases, like if you're not trying to replicate a natural language conversation, I think you can make a great, like real value add using those kind of techniques. Like if it's like a flower shop on the corner, what are your hours? Where's my order? And that's like it. Then yeah, like a tool like that, I think there are many, many, many use cases that will be applicable. So that's how I think about that. It depends on the use case. In terms of being able to do it in the long run, drag and drop tools for everything. I can't write any computer program using drag and drop tools, so I don't really expect to be able to do any conversational questions. Like that's how I think about it. Different tools, different jobs. Yeah.
How much of the responses, the programming, the training, do you think is actually common across your customer base? Like, to your point you just made, maybe it's not visual programming, maybe it's basis, if you want to call it that, to which you then add, for example, customized dialogue vocabulary of given retail store on top of a basis called retail store. I mean, how do you see that among your client base?
I think that is a good observation and accurate. And we see there's potential for value in there in terms of both training, knitting, and launching. So I definitely think that's a true case. The actual text that's like within that is going to vary depending on company and the actual workflow, but there's definitely common patterns. You know, if you're an e-commerce store, generally the customer is going to ask about products first, then select a product, then add it to their cart, and then check out. Like it's a general common pattern. So yeah, I definitely see that being true. Yeah.
So if you have a neural network black box model, I mean, is there any sort of, I mean, we store this, I mean, like, if this is just like a bunch of mutating numbers, or can you use some sort of RDF to store your knowledge in?
Yeah, so like RDF?
Yeah, something like that.
Yeah, so we think about what this is. This is arbitrary graph data, right? So these things here are just triples, where it's a value, and a relation. So a triple store can store, you know, the same kind of information that you can store in other things like RDF. So in terms of like neural networks operating on arbitrary data sets, absolutely, it's going to come. You know, I don't know what the data format is going to be, if it's going to be RDF or something else, but that it works conceptually. It's been proven to work on arbitrary data sets with arbitrary relationships. So yeah, does that answer your question?
Yes.
Yeah. Good. That is it. Anything else, guys? I hope it was informative.